Hi everyone, this lesson is going to focus on evaluating square roots and cubed roots and fourth roots and using rational exponents and converting between the two. Like how do you go from, for example, how do you go from the notation x to the 5/2? So that would be a rational exponent, rational meaning it can be written as a fraction, so fractional exponents. How do you convert that to the notation of a root? So the 2 would be the root, and the 5 would be the exponent. So this would be like the square root, because there's like an invisible 2 here, x to the 5th power. Or for example, you could write the square root of x and then to the 5th power outside of the square root symbol. So that's what we're going to talk about in this lesson, and we're going to do the first 2 lessons of Unit 3 in the Algebra 2 textbook, just because I think this is a harder topic, so getting you guys exposed to it before you take Algebra 2 will be helpful, because then you'll see it again for the second time, and that'll hopefully help you make a little more sense. And then after that, we're going to go back to Chapter 1 of the Algebra 2 textbook and review graphing quadratics and factoring. All right, so like I was saying, when you have a rational exponent, such as a over b, so a fraction, if you want to rewrite it in radical notation, then the denominator of the exponent, of the fractional exponent, becomes the root, or what we call the index, and then the numerator of it becomes the exponent of the variable or the number that's being raised to a power, so the base. All right, so that's your notation here, and then b can't be 0 because that you can't have 0 in the denominator. Okay, so here we're going to change between radical form and rational exponent. So also, if you have radical form, so if you have the nth root of something, then to rewrite it as a rational exponent, you write a to the 1 over n. So n is the denominator, so that's the root, or the index, and then the 1 is the exponent. So if a doesn't have an exponent, then you would just call it 1. So here, some of these we would just evaluate. I'm not going to go over these. I think the most of the things I'm going to say are the trickier ones. So like, for example, if 2 to the 5th is 32, then the 5th root of 32 is also 2. So it's kind of useful to know your 2's, right? So 2 squared is 4, cubed is 8, to the 4th is 16, etc. And then if you have negatives being raised to a power, if the power is even and the negative is in the parentheses, so it's all being raised to the second power, then it becomes positive. So this would be positive 4, and this would be positive 16. But if the exponent is odd, then you're always going to have like one negative left over, so you'd have 3 negatives. So this would be negative 8 and then negative 32. All right, so for these ones, we have to know 2 things. We need to know that the square root of -1, or any even root of -1, is equal to I, because I squared is equal to -1. But if you have an odd root, like the cubed root of -1, then that just comes out to be -1. So for these ones, if you have an even root, then it's going to be like the square root of 4 is 2, but it'll also be 2i because this was negative. So this one would be 2i as well. Okay, for these ones, you'll have the cube root of -1 will come out as -1, and so you'll have just -2. And then this will be also -2. Okay. So for odd roots, if a is negative, then it comes out to be negative. If a is 0, it comes out to be 0. If a is positive, it comes out to be positive as well. And then I think the even roots were up here. If a is negative, it becomes I. If it's 0, it's 0. If it's positive, it's still positive. Okay, so for some more examples. So we're just converting between the two. So 2 to the 1/3 would be the cubed root of 2. Here, if I have the square root of 2 to the third, I would rewrite it as 2 and then to the 3/2 because there's an invisible 2 here because we're talking about the square root. So if there's not a number there, then you can assume it's 2. But then this one would be 2 to the 2/3 because the root is 3, so that would be the denominator. Okay, this one would be the 6th root of x and then to the 7th power. And then this one would be the cube root of 2t. This last one, we would keep y plus 2 in parentheses and then to the 2/5. All right, so now let's do some practice with evaluating. So they're saying that the root is 3 and then the number under the root is negative 216. So we've got the cube root of negative 216. So since it's the cube root of the negative number, the odd power of a negative, then it comes out to be negative. And then 6 to the third power, 6 cubed, or the cube root of 216 is 6. So that would be negative 6. All right, so here we're talking about the fourth root of 81. The fourth root of 81 is 3 because 3 to the fourth power is 81. All right, this one, we've got the cube root of negative 64. So since 4 to the third power, 4 cubed is 64, this would come out to be negative 4. Okay, so now we're going to simplify more things. So here we've got fractional exponent, so we'll rewrite it as the square root of 16 and then to the third power. So that's the first step. And then you would go ahead and evaluate the square root of 16, that would be 4. And then you would do 4 to the third power, which is 64. And so that would be your final answer for evaluating. You want to get it in simplest form. All right, for this one, we didn't talk about this yet, but remember if you have a negative exponent, then you have to put that number over 1 or under 1. So this would be 1 over the 5th root of 32 to the third power. So you know that the 5th root of 32 is 2, so we've got 1 over 2 to the third power, which would be 1 over 8. Number 4 on here, we're doing the, wait a minute, I thought there was a number 4. Oh, it's down here. Okay, so here we're doing the square root of 4 to the 5th power. So the square root of 4 is 2, the 5th power is 32. And then here we have 1 over the square root of 9, which is just 1/3. So, okay, this says evaluating using a calculator. Okay, so I was wondering about that. Like, I don't know if we know how to do 12 to the 3/8 in our head. So we get to use our calculator for this part. So take out your calculator. So this is how you would type in, well, for this one, you'll just do 12 exponent, and then you can write it as shown, 3 over 8, or you can use the fraction button. So let's put 2.54. Okay, now how do you write it like this? So there's two ways. You could rewrite it as a fractional exponent. So you could say 7 to the 3/4 and then do it like we did the other one. Or you could say parentheses math and then do the option number 5 and then put a 4 for the root, a 7 for the, 4 for the index, 7 for what goes in the square root symbol, and then to the third power. So that gives you 4.30. Okay, now we're going to do a little bit of solving for x. Okay, so first step for number 1 would be to divide both sides by 4. And 128 divided by 4 is 32. So then you know that the 5th root, you can take the 5th root of both sides. The 5th root of 32 is 2. All right, for this one, First step would be to take the fourth root of both sides. I don't know what the fourth root of 21 is, so I'm just going to leave it like that. Remember those from something that we learned from Algebra 1 is that whenever you take the square root, and in this case, and whenever you take an even root, you have to consider the plus or minus. So we have to do plus or minus the fourth root of 21. So then if I wanted to write this in exact form, I would add the 4 over, and I would say x equals plus or minus the fourth root of 21 plus 4. But if I wanted to get decimals, then I would put this into my calculator 2 different ways. The regular fourth root of 21 plus 4, and then negative fourth root of 21 plus 4. So we'll do math, go down to 5, fourth root of 21 plus 4. Make sure you get out of the parentheses, out of the radical symbol. And then negative that. So 6.14 and 1.86 would be your answers there. Okay, so this one is similar. We'll have x plus 5 equals plus or minus the fourth root of 16 after we take the fourth root of both sides and then subtract 5, I mean. So you could write it like this, or you could plug it into your calculator. I'll let you try it. You just get negative. Oh, I'm sorry. I was thinking the cube root of 16. The fourth root of 16 is 2. So this would be plus or minus 2 minus 5. So if you know it, then you can evaluate it. So this would be regular 2 minus 5, and then negative 2 minus 5. So this would give you negative 3 and negative 7 for your answers. All right, this one, divide by 1/2, or I would multiply both sides by 2. So that would be what you would do first, and then you would take the fifth root. So this gives us 10/24. And then if I take the fifth root, I don't need to do plus or minus here because I'm taking an odd root, only when you're doing an even root. So do you know the fifth root of 10/24? Let's try it out. 10/24. It's 4. So x is 4 in that case. So a complicated expression can actually be pretty easy to solve. All right, and then one more. A study determined that the weight W in grams of coral cod near Palawan, probably pronounced that horribly wrong, Island, Philippines, could be approximated using this model where L is the coral cod's length. Estimate the length of a coral cod that weighs 200 grams. So if we plug 200 in for W, we're solving for L. So we'll have 200 equals 0.0167 L to the third power. Divide both sides by, so our plan is going to be to divide both sides by this number and then take the cube root. Okay, so let's take 200 divided by 0.0167, oops, and then take the cube root of that answer. Remember, I go to math to get my cube root button. So 22.88. All right, so that is all for today. Hope you enjoyed this lesson, and I hope you guys have a great day.